In one of the most astonishing discoveries in modern astronomy, the NASA James Webb Space Telescope has detected a gigantic black hole speeding away from its host galaxy at more than 4 million miles per hour. Scientists around the world are calling the discovery revolutionary because this black hole is behaving in a way never seen before. For decades, black holes have been viewed as destructive cosmic objects. Their gravity is so powerful that not even light can escape once it crosses the event horizon. Normally, black holes are associated with destruction, swallowing stars, gas, dust, and sometimes entire planetary systems. But this newly discovered runaway black hole appears to be doing the exact opposite. Instead of destroying everything around it, the black hole seems to be helping create new stars as it races through space. Astronomers believe the object may have been violently ejected during a collision between multiple supermassive black holes. As galaxies merge over billions of years, their central black holes can interact in chaotic ways. In rare cases, gravitational forces may become so extreme that one black hole is thrown out of the galaxy entirely, like a cosmic slingshot. That may be exactly what happened here. As the black hole tears through surrounding clouds of gas, it compresses the material in front of it. This pressure causes the gas to cool and collapse, triggering star formation. Behind the black hole is an enormous glowing trail filled with newborn stars stretching more than 200,000 light-years across. To put that into perspective, the trail is longer than the diameter of the Milky Way itself. The discovery shocked astronomers because it suggests black holes may not always suppress star formation. Under certain conditions, they might actually help create stars and reshape galaxies in unexpected ways. The research team, led by astronomer Peter van Dokkum, published the findings in the astrophysical journal Letters. Additional evidence from the Hubble Space Telescope helped confirm the unusual observations. Scientists say the black hole likely originated from a rare three-body interaction involving multiple supermassive black holes during a galactic merger. When galaxies collide, their central black holes eventually spiral toward each other. If a third black hole enters the system before the first two merge completely, gravitational chaos can erupt. One black hole may be launched away at incredible speed while the others remain behind. What makes this event even more fascinating is the visible wake left behind. Webb's infrared instruments detected a narrow stream of bright young stars formed directly in the black hole's path. This cosmic trail acts almost like the wake behind a speedboat moving across water. Researchers are now studying whether similar runaway black holes exist elsewhere in the universe. If more are found, scientists may need to rethink long-standing theories about galaxy evolution and black hole behavior. But that was only the beginning of Webb's incredible discoveries. The telescope also captured breathtaking new images of ARP 220, one of the most energetic galactic collisions ever observed. Located roughly 250 million light-years away in the constellation Serpens, ARP 220 is classified as an ultraluminous infrared galaxy because it emits more energy than a trillion suns. Around 700 million years ago, two massive spiral galaxies crashed into each other, unleashing an enormous burst of star formation. The collision created dense regions packed with gas, dust, and young stars. Webb's infrared cameras revealed details never seen before, including two glowing galactic nuclei still surrounded by rotating rings of star-forming material. Scientists observed huge tidal tails extending outward from the merger. These stretched structures formed as gravity twisted and pulled stars and gas during the collision. Webb also detected reddish-orange filaments made of dust and organic compounds scattered throughout the system, creating a dramatic and chaotic appearance. Previous radio observations had already identified more than 100 supernova remnants inside a relatively small region of ARP 220, proving the galaxy is experiencing one of the most intense starburst events known. Webb's sharper infrared vision now allows astronomers to study these violent processes in extraordinary detail. Researchers describe ARP 220 as a cosmic laboratory where they can observe how galaxy mergers transform the universe. Events like these may help explain how giant galaxies formed billions of years ago. As scientists continued studying the endless stream of information sent back by the James Webb Space Telescope, they stumbled upon a discovery that may become one of the most important astronomical revelations of the modern era: galaxies that appeared to have formed only a few 100 million years after the Big Bang itself. To understand why this shocked the scientific world, it is important to realize just how far away these galaxies are. The universe is estimated to be around 13.8 billion years old, and the light from these ancient galaxies has been traveling through space for more than 13 billion years before finally reaching Webb's mirrors. In effect, the telescope is functioning like a time machine, allowing humanity to observe the universe as it existed near the very beginning of cosmic history. For decades, astronomers believed they had a relatively solid understanding of how the first galaxies formed. According to standard cosmological models, the early universe after the Big Bang was a dark and chaotic place filled mostly with hydrogen gas, tiny fluctuations of matter, and intense radiation. Over hundreds of millions of years, gravity slowly pulled matter together, eventually forming the first stars and primitive galaxies. These earliest galaxies, scientists believed, should have been small, dim, irregular, and immature. But Webb's observations painted a very different picture. Instead of tiny faint structures, the telescope discovered galaxies that appeared surprisingly massive, bright, and highly organized. Some seemed to contain enormous populations of stars despite existing at a time when the universe was still in its infancy. Others displayed spiral-like structures and advanced levels of development that should have taken billions of years to achieve according to existing theories. The discoveries immediately sparked intense debate throughout the astronomy community. Some researchers initially suspected the observations might be misleading. Perhaps the galaxies were actually much closer objects distorted by gravitational lensing, an effect where gravity bends and magnifies light from distant sources. Others wondered whether dust, unusual brightness, or observational errors were causing scientists to overestimate the galaxy's size and age. However, as more data arrived, the evidence continued growing stronger. Follow-up observations using Webb's infrared spectrometers confirmed that many of these galaxies truly belonged to the universe's earliest epochs. Their immense distances meant astronomers were seeing them exactly as they existed shortly after the Big Bang. This realization created a major scientific puzzle. How could galaxies become so large and mature so quickly? Some scientists now believe the process of star formation in the young universe may have happened far more rapidly than previously imagined. Instead of slowly building galaxies over billions of years, the early cosmos may have experienced explosive bursts of star creation capable of producing massive galactic systems in remarkably short periods of time. Another possibility involves the mysterious substance known as dark matter, which makes up most of the universe's mass yet remains invisible and poorly understood. Certain researchers speculate that dark matter may have clumped together more efficiently in the early universe, accelerating galaxy formation far beyond current predictions. Others point toward supermassive black holes. Modern astronomy still struggles to explain how black holes containing millions or even billions of solar masses could appear so early in cosmic history. Webb has detected signs of enormous black holes existing when the universe was less than 1 billion years old. Some theories suggest these black holes may have acted as cosmic engines, pulling in matter and helping galaxies grow at astonishing speeds. There is also growing discussion about whether existing cosmological models may need significant revision. The current standard model of cosmology has successfully explained many large-scale features of the universe, including cosmic expansion and the distribution of galaxies. Yet Webb's findings hint that important pieces of the puzzle may still be missing. If galaxies truly evolved earlier and faster than expected, scientists may need to rethink aspects of how matter behaved after the Big Bang itself. What makes these discoveries possible is Webb's extraordinary technology. Unlike ordinary telescopes that primarily observe visible light, Webb specializes in infrared astronomy. This capability is crucial because the expansion of the universe stretches ancient light into infrared wavelengths through a phenomenon called redshift. As space itself expands, wavelengths of light become longer and redder over time. Extremely distant galaxies therefore become nearly invisible to traditional optical telescopes. Webb's powerful infrared instruments were specifically designed to detect this stretched light, allowing it to peer deeper into the universe than any observatory before it.